Okay, we are on the quotient rule, and this is in the middle of page 13. It has a box. It says, in general, if x is non-zero and m and n are positive integers, then x to the m, so x raised to the m power divided by x to the n power is equal to x to the m minus n power. And this is called the quotient rule. Okay, and so I'm going to show you why that is in a moment. So here's exercise 71, or 21, with 7 raised to the 9th and divided by 7 raised to the 6th. And so if you're following this rule, you'd see that it would be the same as 7 raised to the 9 minus 6, which would be 7 raised to the 3rd power. If you want to see that rule and you're like, I don't know why that works, and then watch this. So 7 to the 9th power is 7 times 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 7 divided by 7 to the 6th power. So that would be 7 times 7 times 7 times 7 times 7 times 7. Okay, so now if I simplify this, 7 divided by 7 is 1. 7 divided by 7 is 1. 7 divided by 7 is 1, and so on. I'm basically just eliminating those and simplifying it, and I have 7 to the 3rd power left. 7 times 7 times 7, which is that. So that's an example of why it works. If you ever forget the rule, you can always expand it out. I mean, you can't always because it might have a large power. Okay, so exercise 22, same thing, we are going to have negative 5 raised to the 16 minus 7. For this exercise 23, you have 8/5, a fraction, keep it in parentheses, raised to the 9 minus 2. For exercise 24, you have 13 raised to the 5 minus 4, which would just be, right, 13, because 13 to the 1 power is just 13. But we'll leave it like that just so you see how this rule works. You could simplify it if you'd like. Okay, to the next page, to exercise 25. I'm going to rip it out. Having issues. Space. So exercise 25, which is a over b, it's a fraction, raised to the 9 minus 2. And that's what that solution is. And exercise 26 would be x raised to the 5 minus 4. And can the following expressions be written in simpler form? So we look here, and we have 2 to the 7th divided by 4 to the 2nd, which is equal to 2 to the 7th divided by 2 to the 4th. 4 to the 2nd is 16, as is 2 raised to the 4th power. So yes, it can, to 2 to the 7 minus 4. Exercise 28, same thing, we have simplified. 3 to the 3rd power is 27, so now this could be 3 to the 23 minus 3 power. Exercise 29, we have 3 to the 5 minus 2 power, and we're going to multiply that time, well, the multiplication sign should be a little further down here, times 2 to the 8 minus 3 power. Let's just ignore that little thing. Okay, so we could combine them like that because it's multiplied. And then for exercise 30, you have negative 2 to the 7 minus 5 times 95 to the 5 minus 4, which is just 1. So 95 to the 1st power. Okay, exercise 31. In exercise 31, is more of a challenge. I think that both of these two problems are a challenge. So if you'd like to get them done, you can. And I'll have a 3rd video with the challenge problems done, but this is just bonus, so that we don't have to extend extend this. This is already a pretty long lesson. So lesson 2, exit ticket, we're skipping for now. We'll get back to it. Lesson 2, homework helpers here if you need help reviewing what we just talked about. And then the lesson 2 problems that will be on assessments. And that's where you're going to access it on Google Classroom. Okay, bye.